So let's try this example number 4 here. So as you can see, it is a rectangular beam, but this time it has a rectangular hole at the top. So what will we do if we are given a problem in which the shape has a hole? So the technique is very simple. You just need to subtract the hole. So these are the dimensions. The hole is a square with dimension of 150 by 150 mm, and you can see the remaining dimensions. So for letter A, we are asked to solve for the bar Y, and for letter B, we are asked to solve for the moment of inertia with respect to the neutral axis. So let's solve for letter A. So solving for bar Y. Okay, so using again Varignon's theorem, we have area total times bar Y is equal to summation of areas times their y's. Okay, so what's our area 1, area 2, and so on? In this example, we can solve this in many ways, but I will teach you the easiest way. So the easiest way is that our area 1 is the rectangular shape with no hole. Okay, so this is our area 1. So this is our area 1. Our area 2 will be the hole. So this is our area 2. Area 1 will be, what is the total width? This is 450, and the total height is 650. So 450 by 650. So our area will be 450 times 650. So that's our area 1. 292,500. Our area 2 will be the area of the hole. So this hole here is 150 by 150. So 150 times 150 is equal to 22,500. So this is millimeter square, millimeter square. Next, let's solve for the y of the two areas. So y1 is equal to, so our y1 is just the half of the total height, because we assume that our area 1 is the whole area. So again, that is not an assumption. Our area 1 is the whole rectangle. So the y1 is just the half of the total height, or 650 over 2. So this is 325 mm. Next, our y2 is just this distance here. So y2 is 150 over 2. Again, our y is with respect to the top of the section. So y2 is half of 150, or 75 mm. So how do we apply Varignon's theorem if our shape has holes and using this process? Our area total will be area 1 minus area 2. So the whole rectangle minus the rectangular hole. So area 1 is 292,500 minus 22,500. So 270,000 millimeter square. Next, we can now solve for bar y. Bar y is area 1, y1, minus the whole divided by our total area. So bar y is 292,500 times 325 minus, what's our area to? 22,500 times 75 divided by 270,000. So bar y is 345.833 millimeters. You can solve this by using a different process, but then this will give you a more longer solution, because if you will divide this into areas, you will get 3 areas. So this is area 1, area 2, and area 3. And the solution will be longer. But if you will use this process, the solution will be shorter and much easier. So we have already solved for bar y. Try to solve this using the longer solution. So it's up to you, what will you use? Where will you be comfortable with the shorter solution or the longer solution? As long as you have the correct answer and the correct process. Okay? So letter B is I and A. So in letter A, we use only 2 areas. The area of the whole section minus the area of the whole. So in letter B, we're gonna use same process. So the I and A of the whole section minus the I and A of the whole. So for the I and A of the whole section, so that is I and A1. Okay, so for I and A1, we're going to use transfer formula, since the neutral axis does not coincide with the centroid of area 1. So I and A1 is equal to IG1 plus A1 D1 squared. For IG1, the base of area 1 is 450. The height is 650 raised to 3 over 12. So this is equal to 1.030 times 10 raised to 10. How about our A1 D1 square? Okay, so our A1 is the area of the rectangle, the whole rectangle, without the hole. So this is 450 times 650. 292, 500. Next, what's our D1? So D1 is the distance of the centroid of the rectangle with respect to the neutral axis. So this is our neutral axis. The neutral axis of the section. This is the centroid of the whole rectangle. So this distance here is our D1. So what will be our D1? Our D1 will be, this distance is bar Y. Our D1 will be bar Y minus Y1. So this distance is, so from letter A, this is Y1. Okay, so our D1 is Y bar. So bar Y minus Y1. Our bar Y is already solved. So 345.833. Our Y1 is already solved in letter A. It is half of the total height, or 650 over 2. So D1 is 345.833 minus 325. So 20.833. Now we can solve for I and A1. So this is IG1 plus AD squared. So 292, 500 times 20.833 squared. So this is equal to 1.043 times 10 raised to 10 mm4. How about our I and A2? So for I and A2, same process. So I and A2 is equal to IG2 plus A2 D2 square. IG2, so remember this is our area 2, the hole. This hole here is the area 2. So this is 150 by 150. So our IG2 is, what's the base? 150. Height is 150 also, raised to 3 over 12. So IG2 is 150 raised to 4 divided 12. So 421, 87500. Next, A2. A2 is 150 times 150. So 150 raised to 2, 22,500 mm square. Next, D2. So what's our D2? D2 is the distance of the centroid of this hole with respect to the neutral axis. So this is D2. So our D2 is just bar Y minus Y2. So Y2 from letter A. So this distance here, if you can recall, this is Y2. So D2 is bar Y minus Y2. So bar y is 345.833 minus y2 is just half of 150 or 75. So d2 is 345.833 minus 75. So 270.833. So our I and A2 becomes IG2 plus A2 D2 square. So this is 169.2574.063 mm raised to 4. Now, our INA is equal to INA1 minus INA2. It's minus because INA2 is whole. Okay? So the answer is 8737.425.937 mm4. So this is the answer for letter B. 8737.425.937 mm raised to 4. Let's try this example number 5. So it is composed of rectangular and triangular sections. We can solve this in the longer way by dividing the shape into 4 different shapes. So this is area 1, this is area 2, and this 2 here, area 3 and area 4. We can solve this that way, but then there is a shorter process. So let's try the shorter process, and I recommend you to use the shorter one. So let's erase this. So what will be the process in solving this example? Okay. So we will use the same process with that of example number 4. So we will have a whole rectangular shape minus the whole, or in Tagalog, the butas. So this is the whole rectangle. This one. This is the whole rectangle. The dimension is 600 by 600. And then the whole is composed of 2 triangles with dimensions 200 by 450. Okay? So let's solve for letter A, bar Y. So we have 2 areas here. The area of the whole rectangle and the 2 triangles here. Okay? So for area 1, our base is 600. The height is also 600. So this is equal to 360,000 mm raised to 2. How about our y1? So y1 is just half of the height. So if this is area 1, okay, this is your area 1. Your area 2 will be the triangles here. This will be your area 2. So this is 600 by 600. And these two triangles here is 200 by 450. Okay? So your y1 will be just half of the 600. So 600 by 600, so the whole rectangle height is 600. So half of 600 is 300. So 300 millimeters. Next, our area 2. We can combine these triangles as area 2 because they have same dimensions and they lie on the same location. Okay? So they have the same y with respect to the top of the section. That's why I combine them into A2. So our A2 will be, what's the formula for triangle? It's base times height over 2. So since these are two triangles, we have 2 times base, 200, height, 450. So divide 2. So this is the area of one triangle and times 2. So this is 90,000. Okay? Next, y2. y2 is the distance of the centroid of these triangles with respect to the top. So this is y2. So what's our y2? y2 is 600, the overall height. So the overall height here minus this one, this distance here. So what is this distance? This distance is 1/3 of the height of the triangle, or height of the triangle over 3. Again, y2 is the total height minus this distance. So the total height is 600 minus 450 over 3. Okay? So this short distance here is 1/3 of the height of the triangle. So 600 minus 450 over 3 is 450 mm. Okay? Next, what's our area total? So area total is the area of the whole rectangle minus the two triangles here. Since these are the holes, as in HOLES, butas, so we will deduct it from the whole section. So area total is A1 minus A2. Okay? So A1 is 360,000 minus 90,000, so that is 270,000. Now we can solve for bar y using Varignon's theorem. So A1 y1 minus A2 y2 over A total. So solving, we have 360,000 times 300 minus 90,000 times 450 divided by 270,000. So our bar y is 250 mm. You got it? So going from the top, what I did is that my area 1 is the whole rectangle. So just imagine this is a whole rectangle. So the dimension is 600 by 600. And my area 2 is the combination of the holes, the triangular holes. Okay? Okay, so let's proceed to ion A. So ion A is equal to ion A1 minus ion A2. So for ion A1, we're going to use transfer formula. So this is Ig1 plus A1 D1 square. Ig1 is, since this is a rectangle, this is BH cubed over 12, in which B is 600, H is 600 also. So just see this figure here, over 12. So our Ig1 is 600 raised to 4 over 12. So 1.08 times 10 raised to 10 mm raised to 4. Next, D1. Okay, we already solved for area 1 and letter A. So this time we will solve D1. So D1 is the distance of the centroid of the rectangle with respect to the neutral axis. So where is the neutral axis here? So neutral axis is located 250 millimeters below the top of the section. So this is our neutral axis. Okay, this is our neutral axis. So this is bar Y. So let's solve for D1. So where is the centroid of the rectangle? So the centroid is, this is 250. The centroid is 300 mm, isn't it? So this is 600 by 600, therefore the centroid is just half of 600 or 300. So it is located here. So this distance is 300. This is Y1. Therefore, this distance here is D1. So D1 is Y1 minus bar Y. Or Y1 is 300 minus 250. So D1 is 50 mm. Ion A1 becomes 1.08 times 10 raised to 10 plus A1 360 times D1 square, or 1.08 times 10 raised to 10 plus 360,000 times 50 square. So 1.17 times 10 raised to 10 mm4. So the calculation does not end here because we are required to solve for ion A2. Ion A2 is the moment of inertia with respect to the neutral axis of the two triangular holes. Okay? So let's solve for ion A2. Okay. So solving for ion A2, ion A2 is Ig2 plus A2 D2 square. Okay? So what's our Ig2? Ig2 is, since we have two triangular holes here, so times 2. So 2 times, what's the Ig for triangle? So it is BH cubed over 36. So our base, the base of one triangle is 200 and the height is 450. So base times height raised to 3. So this is 5 over 36. So this is your Ig2. So Ig2 is 10125, then 5 zeros, raised to 4. Next, A2. A2 is already solved in letter A, so this is 90,000. And if you can remember, our Y2 in letter A is 450 mm. Okay, so what is D2? D2 is the distance of the centroid of this triangle. So this is the centroid with respect to the neutral axis. So that is D2. So our D2 is just this distance here. This distance here is Y2. And this distance here is bar Y. Therefore, this distance is Y sub 2 minus bar Y. So D2 is Y2 minus bar Y. Our Y2 is 450 and bar Y is 250. Okay? So D2 is 200 millimeters. Now we can solve for ion A2. So this is very easy as long as you are following the process. Okay? So this is Ig2 10125 plus area 90,000 times 200 raised to 2. So this is equal to 4612 5 1 2 3 4 5 mm4. So the final answer for letter B is ion A1 plus ion A2. So this is 1.63125 times 10 raised to 10 mm4. So if you have additional questions, you can private message me through the messenger. So for the problem number 2 in your seat work, try to solve this section in the inverted form. So problem number 2 for seat work. Okay, so this is your problem number 2 for seat work number 1. So same section but inverted, and it has a square hole here. Okay, so this is 600. So this is 150, 150, then 300. Okay, so this hole here is 150 by 150. Okay, so 150, 25, 25, 200, 200. So this one is 200. Okay. So the required are bar Y, letter B, I, and A.